We're going to do 7, 8, 9, and 10. And so what we have here is where we're wanting to describe errors. We've got Amy's Ice Cream. He's going to do a new shop if more than 40% of local residents prefer his situation. So, describe a type 1 error. Type 1 error is going to be type 1 error when the null is really true, but you get a sample. So the proportion of local residents that prefers ice cream is 40%, but you get a sample that causes us to reject the null, and then we think that the alternative is true. So we think that more than 40% prefers ice cream. Number 8, describe the type 2. Okay, type 2 is type 2 error, type 2 error. We have no evidence, and so we fail to reject a false null hypothesis. So the null hypothesis is false. The proportion of local residents that prefers ice cream is actually greater than 40%, but we got no evidence. We did not get evidence to reject that it's 40%. Okay, so he's not doing a new store, and he could. All right, next is type 2 error. They actually tell you beta, and I don't think we've had something exactly like this, but we have talked about how power plus type 2 error is 100%. We did that with our pictures, how we said when we drew our pictures, here's one curve, and then here's the other curve. And here was our type 2 error. Okay, if that's our alpha, here was our type 2 error. And then this section over here was our power. Power is the probability to reject the null if it's false indeed. Okay, so that was power plus type 2 error plus type 2 error was 100% of a curve. So then that lends itself such that when you have this problem, power is 1 minus the beta. So it's just 1 minus 0.16, so it's 84%. Okay, 84% of the samples would lead me to reject. So here's the 84%. All of these samples over here would lead me to reject the null hypothesis if it is indeed false. Power is the probability to reject the null, if it's false indeed. All right, and finally, number 10 is pretty straightforward. It is just a interval, a straightforward interval that you would do. And so we can take a look at that and see that our conditions, we've got the 200 is our sample size. We're making a 98% interval. Okay, so you can see that our that what we've got here is the conditions. Okay, 200 less than 10% of all sharks, and then 12 of them. Where did I get that 12 from? Oh, interesting. See, look, 12 of the 200. It was hidden in words. So 12 of the 200 occur in the deep waters. All right, so that's where that came from. Now, remember that this is your formula for confidence interval. This is your critical value, your Z star. That, for a 98% confidence interval, let's talk about how to get that. Your interval is supposed to have 98% in the middle. So if it has 98% in the middle, then that puts 1% on each side and in each tail. So if I want to find that critical value, then that comes from inverse norm of 0.01. Okay, and so that's what I have right here, inverse norm of 0.01. So there's your 2.33. Your standard deviation is coming from the formula right here, standard deviation from the P times 1 minus P over N. That's your standard deviation. And of course here is your 6%. That is coming from the sample results. 12, which was in words in the paragraph, out of 200. Okay, so that's where that came from. You had to read that carefully. So I'm 98% confident that the true proportion of shark attacks that occur in deep water is between 2.1% and 9.9%.